Hello, welcome to Enots Engineering. I'm Alan. In today's video we're taking a look at last year, all the videos that we did last year are there, small sections of each one. So let's go into the workshop, see what we did. Push it up against the jaw. I need 4 of these in total, and this is what they fit into. Now these little discs just fit in there. Did you guess what they were for? Then you have 2 screws that tighten the sensor onto the brackets that I've already fitted on the wall, and the wire comes out on the right hand bottom side. Here's the lamp fitted to the wall, so that seems to work okay. Turn that round, put it back in the chuck. And that's the first one made. Now I'll start to make the 2 washers. The plastic bush fits into the hole in there. The seat. And the bolt goes through there down inside, to do that from this side. And underneath here, plastic washer. Then the nut goes on. And you tighten it up just by using the socket. And tighten the holding underneath with a spanner. And just lift the lid up and screw on the caps. That saved me £70. Now I want to select a speed from the feed list. If I select figure 2, it will give me a range of feeds and speeds by only changing 1 gear once I set the initial speed. This is a 24-tooth gear fitted to the stud. There's a key there that lines up with that. The gear at the back is on there permanently. There's nothing to stop that turning because this is your end of the lead screw. So when the other gears are on, you'll be able to just nip these up. And now the hard part, to get them all engaged and moving freely. Go into there. If I engage this, you'll see they all engage. Turn the screw to engage the clutch, and it should start to move. So go faster. Dial indicator, a lever type, and a digital caliper, 6-inch. And this is a metric dial indicator. The range is from 0 to 0.4 on each side. Has a yellow background. On the end of the probe is a steel ball. In the box it comes with a dovetailed attachment to hold it. The resolution is 0.01. Accuracy is 0.02 of a millimetre. Comes with the battery. In this case it was already fitted. You have 3 buttons. One's the on off, one's to zero it, I want is to change between the three functions. And the functions are millimetres, inches, or fractions of an inch. So if I switch it on, that's in millimetres. When I press this once, that's in inches. Press it again, this will be fractions of an inch. I'll untap this, a 6mm tap in the end. Slow it down. So I slowed it right down, it's only doing 96 RPM, but as I go in further I'll start to speed it up. And the saw blade fits on there. You can lock that in position. So you can move the saw blade backwards and forwards in front of the wheel. You need a piece of broken hacksaw blade, magnetic base, it's about 3 inches long, it doesn't matter, it's not important. This is the tap that broke, and I put some soldering flux on the pipe. I'm using some new joints so that can go back on there. These have solder already in them. I have cleaned and put flux on the pipework. The solder's melted. Should do. That holds the olive in position so I can fit the pipe on. I fitted the tap mounting bracket to the wall and fitted the tap to the bracket using some PTF tape. The other part goes through the bigger hole and just screws together. And then you can turn it on or off without having to get the ladders every time you want to turn it off. Easier. So I've lined the lines up with the tool, and then we'll cut from the outside to the centre. We can then cut the other face parallel to the first face. Then rotate the table and line up the third face. Cut the third face to the centre, and then finish the fourth face parallel to the third. And now we'll see if it fits. The links are held together with these little T pieces, and it's easy to remove. So all you do is, when they're locked, so they're across the belt, and to unlock, just twist it to that position. What you can do is bend the belt up and over to undo it. Do it on the second one and take a link out. Or if you wanted to add a link, you can put these back in. But these are the 3 chuck keys I'll modify. And that's 2 balls on the end of the handle. And I made the other chuck keys exactly the same way, but the ball diameter is 15mm. So I'll turn the screw to get knurls to come together. Come along. tighten it up a bit more. Go in. Another tighten it up more. Come out. Pull the lever back. That's released it. So you can have a look at the knurl. What I need to do is just put a file just on the edge because it's sharp edge now. The lever here, as I move the lever up, it closes the knurling wheels together at the last setting. On the end of each arm was a small plastic piece. Let's just take this one out. You can just pull it out of the end of the arm and refit it in the new position. These ends give you a hook so you can hang the bird feeders from. Now that plastic bit I made will fit in there. And what I've done is bolted on just a tray that you can buy at garden centres for bird feeders. That clips in there. That gives me a bird feeder on the top. And then you can hang the other feeders off the arms. There's a good selection of tools this year. And even more tools. It also comes with a calibration certificate, which we'll look at later. If we look at one of the blocks, this is the 30mm block. You can see it's marked with the size, and at the bottom it has the number of the block. Each block has a different part number and they're listed on the calibration certificate. But I've taken two out the set. This is a 30mm one. This one is a 2mm one. You can see they both have the gauge ID on the bottom there. And I've cleaned the protective film off the mating side. It's saying on that slip gauge it is plus 0.25 of a micron. Now that is that small that if you're milling or turning you wouldn't worry about that distance. Grade 0 is inspection grade, grade 1 is tool room and grade 2 is workshop grade. Having a flat face, your indicator will run on the outside diameter regardless of the height. Set the dial indicator to 0 there, wind it back down. So over that length it's 1 thou, which is quite good I think, thou in a. So I'm not going to try and correct that because I can only get worse. I doubt whether I'll get better than that. Self-centering 3 jaws, but on this here, on each jaw you have an extra screw that you can adjust the jaw position. So what I want to do is take this off, we'll strip it down and see how it works. The back plate should come off. You see how this works. There are 3 bosses. where the adjuster screw runs against, and it just pushes this back plate to one side or the other. The chuck's held on by cap heads that are built into the chuck here, and the chuck key is the same size as the cap head. That cap head goes straight away through the chuck into the back plate and pulls it up. That's the type of screw that holds the chuck to the back plate. That's the chuck key for the 4-jaw chuck. Oh well, that's it for today. Hope that's useful. Hope you enjoyed it, and we'll see you next time on Enots Engineering.